Hello, everyone. This is a session, will be a nice session to kind of hear from some of our customers. So I'm just going to briefly talk about kind of our product strategy in AI. I'm Tom Dyar. I'm a product manager in the data platform side. I focus on machine learning and AI, and talk about vector search and what it is, just really quickly. And then I'm going to pass it on to customers that are early adopters that have been trying vector search and using it, and they're going to talk about their use cases. So we have Agimero from Germany and Sabin, customer partner in Brazil. And they have really mission-critical kinds of applications that are very interesting to hear about, and so I hope you guys get something out of this. So, real quick, you can kind of think of what we provide, at least at InterSystems. Of course, we're not OpenAI, we're not Microsoft, we are not developing a lot of, kind of our own big foundation models. We probably will have some models that are specific for our use cases and our object script language. But typically, we think of things in three buckets. So we've got on the left, kind of for application developers, chiefly among this now, vector search, which really turns your all singing, all dancing IRIS database from this, really nice enterprise database, Swiss Army knife database, into a vector database, which allows it to do LLM-powered search. And also in that bucket will be copilots and things like that for developers. In the middle, for solution builders, for people that are really just kind of trying to make applications, we'll have templates, and in that case, like things like quick starts for developers to just quickly put these things into action. And on the right, of course, we have our own IntelliCare medical record system and HealthShare and applications that have end-user interfaces. Those will have their own copilots, and we're rolling out those features as we speak. So supply chain orchestrator has its own copilot assistant that is rolling out, and we have a similar kind of focused product for financial services. And those kinds of experiences really require the specialization that you can get when you customize your chatbot to your own data. And that's what vector search really allows. So you can think of those kind of pictorially in these kind of buckets. Just think about that as InterSystems is talking about what they're doing in this space. But vector search is really useful within the enterprise in this retrieval-augmented generation pattern. So you'll hear a bit about it, you've heard about it for quite a while, but really the concept is just to take a user query, use these embedding models that turn that user query into a geometric representation that captures the meaning of whatever data you're putting into it. It doesn't have to be just text. So depending on that embedding model, depending on the data, it could be images, it could be multimodal, right? So there's different models for all types of applications. But you keep that representation or that computation, the output of that, in your database, along with all of your critical content. And then when you have that query come in, you can get those relevant pieces out of there. And that makes your LLM search, your LLM answer, that much better, because you then say to the LLM, answer this question, but use this information that I'm giving you to answer it. It's information that I've gotten from my database. It's fresh, it's secure, it's what data that I know about, and that's what you should use. And don't hallucinate, don't make anything up. If you can't answer the question based on what I'm going to tell you right now, don't answer it. So it's still a trick. You can still have hallucinations, but this really does allow you to customize the LLMs that you get from these big providers to your data. And we make it really simple from SQL that you might know. but SQL that you can also customize quite a bit. In this case, a very complicated query that uses the vector dot product, which is part of vector search, as one of these geometric comparisons that you're searching over your documents, but also doing a graph type search, which is in the middle, or your traditional keyword search, and you might want to combine all of those. So that is kind of the power of using vector search. In IRIS, it easily integrates your current data to the model, your application. It keeps the solution architecture very simple because you're just leveraging SQL. And of course, it minimizes the risk of getting your data that you don't want out on the internet out there. So you're really just kind of focused on the question you're asking. So with that, I just wanted to kind of give you that kind of broad overview of what vector search is. Think of it, it's part of SQL now in IRIS. It helps you use large language models to build kind of chat with your data applications. Data that can be any kind of data, can be image data, multimodal, auditory, and it's all within the same system in IRIS, where you have your trusted data all the time. Okay, so with that, I'll pass it over to Fabio from Agimero. He's one of the customers that's going to talk about his application.
Hello, welcome everybody. We are from Agimero from Germany, and we would like to show our business case with this vector search. First, quick introduction from us. Our mission is to save money for our customer. That's full stop. That's what we have to do. And our procurement is our DNA. The founders are CPOs, were CPOs in the past, and now how can we save money for our customer? And it's a lot of savings in the process. And for that, we created a platform, a procurement platform that reduced process time from 2 hours from order to payment to 30 seconds. But to order, you have to first to choose your item that you want to order, and that we do with vector search. And now I hand over to Fabio to explain in detail how it works.
Thank you very much, Holger. So the problem we were facing in our procurement platform was mainly that we had, first, a lot of data. We had 11 million items, 26 million if you count the different suppliers and their sources. And all of that data comes, firstly, very unstructured. You have descriptions, you have keywords, you have features, maybe some photos or data sheets that come with it. And every supplier can choose the way they provide that data to us. We are very open when it comes to how we retrieve that data. We want as much as possible. But one effect of this is that it's unstructured and varying different levels of quality. So you might have a supplier that gives you a 400-word description, and then you have a supplier that gives a 5-word description. And they're both selling the same item, and you somehow have to work with that. So based on this data, how do you get sufficient results? Well, at first, so we're not that big of a company that we can manually enrich all of our content. We cannot have 100 employees sit there and type in better descriptions for all of that data. So manual content enrichment just wasn't an option for us. So we had to rely on what the supplier was giving us. And even if we somehow managed to put that data into structured data, you still have a lack of precision, simply because you do not know if the supplier in his description means the same thing as the customer when he's looking for that item. So you might have the customer use a synonym or maybe some other word for something he knows, while the supplier uses completely different words, and you don't know if they're related. So what we did is, as soon as we heard about vector search in the new IRIS version, we started using it, and we instantly saw success in the precision of the items we were getting in our result set. So this is our procurement platform. This is our old search engine. Everything we input into the search term was hammer, simply because it's unanimous in English and German. You see German data here. So a hammer, we all know what a hammer is. And if you look at the first item, kind of makes sense. You have a metal head, you have a wooden handle, that kind of looks like a hammer, so pretty good so far. But if you start going down the list, you might notice, well, those aren't really hammers, are they? They're handles. The supplier did such a good job of connecting his handles to the word hammer that our key text-based search engine gave it a higher priority over other hammers because other suppliers supplied us with less quality in their data. And this is what we were struggling with for the past 20 years. I'm not kidding. This is a process we've been working on for a very long time, and we've always had to manage the efficiency and performance and the quality of the results, and you never get a satisfying result. So let's look at what vector search did. We put the same thing in. We said, give me a hammer, just wrote in hammer, and suddenly we instantly only saw hammers in the top 100 results. There were no hallucinations about anything else. It was just hammers. This is an actual research result, and it's way more comprehensive to the customer. I mean, I, as a developer, I can explain, well, why the old search engine only showed handles, but that's not what the customer wants to see. You need to be you don't want the customer to be frustrated with the results, having him go to the third page to find a different hammer. So with this, we were instantly successful. A nice side effect of using vector search was that we could figure out typos. So right here you can see this is, again, our old search engine. If you searched for the word Hammer, which isn't a word in German either, you got no results. Back in the day, we tried correcting maybe what the user was trying to input, and you start overcorrecting and maybe supplying the customer with items he wasn't looking for. Again, frustration. So we stopped there and just gave no results. And with vector search, we actually got hammers, because what vector search does, it takes the nearest result. It doesn't care if there are any exact results. It takes the next best thing. And in this case, the next best thing were actually hammers, because again, hammers aren't a thing in German. So let's dive a little deeper into the technological part and how we chose what we did and how we did it a little. I won't go into vector search. You'll have other opportunities, but the whole process of choosing the right model. So the first thing we had to do, and the first obstacle a lot of you will have if you haven't started yet, will be choosing the right model, and especially comparing models to each other. What we did was we asked our employees, please handpick 10, 20, 30, 40 items you would expect in a search result set given for a certain search term. So we gave them the word hammer and told us, please pick out 20 hammers you would like to see as different as possible, not just the same hammer in a different color, but like a rubber hammer, a metal hammer, and so on, and put that into an expected result set. We then took our vector search result and compared it to the expected result. Again, this is a very, at first glance, this looks good. So vector search down here, you can see the word hammer comes up. Well, actually, the first item in there, it's not a hammer, it's a hammer drill. It just says hammer. So there you had to somehow reliably check the quality of the results without having to look at every result yourself. Again, human time, very, very precious to us. So we had to automate this process somehow. So what we did is, we have our own chatbot running locally in our machine. You can do this in the cloud as well with ChatGPT. And what we did is we took every item of the vector search result and asked, based on the expected results we handpicked for the search term, give this item from the vector search result set a score from 1 to 100 when it comes to correlation and how close they are to each other. And what we achieved was we were able, and we're still in the process of doing this, we were able to, on an even level playing field, compare the quality of different large language models and the embedding models on their scoring. So right here, you can see we started with smaller models to see if we had the right approach. These are two very small models with only 768 dimensions. And we could instantly see that the first model for our search terms and our expected results performed better than the second one, simply because these are text retrieval models, or can be used for text retrieval, but when it comes to models, they have a lot of different use cases. So you have to find out what the right models are. And with this, again, we're still in the process of doing it, because the bigger models, of course, take a little more time. We instantly were able to not only performance-wise compare the models, but quality-wise as well. So now let's look at another lesson we learned from doing this. So let's look at the nomic embed text model we used and the SQL code we ran. Our use case was to retrieve 10,000 items from our 11 million initially. Why 10,000? Well, you could retrieve 15 and just show the 15 to the user. But then you have no control over what you're actually showing to the user. You have to 100% trust the model in what it's doing, and that's not what we wanted to do. And this is where we heard about hybrid search. You can retrieve 10,000 items and re-rank them afterwards to your liking, because in those 10,000 items, I can fairly certainly say there will be hammers in there, and we know that there are, so we just have to re-rank them afterwards, maybe. So when we ran the different SQL commands across the models, I was surprised to see that they only took around 0.1 to 0.3 seconds to execute. And I was very confused because I thought, well, that's a lot of data. It has to look around. Interesting. But then when I ran the loop to get the single items from the result set, suddenly I was waiting 2 minutes for that loop. Turns out this is lazy SQL, as it's called. It's actually only executing when retrieving the data from the result set. So just in case you run into the same problem, that's why I wanted to show that. So we had a wait time of 2 minutes for each search the customer did. And I went to our sales engineer and was like, that's not really acceptable. I need a result in like 10 seconds, best, worst case. And so our sales engineer recommended something to me that is in the new IRIS version. It's the HNSW index. Again, I won't go into the technical detail of what it is and how it works, just wanted to tell you that we are using it because it gave us a huge increase in performance from 2 minutes down to 6 seconds in retrieving 10,000 items from 11 million. And it's a nearest neighbor index that basically reduces the quality of the items a little bit, but increases performance by a magnitude. And every performance boost, of course, comes with a cost, and that cost can be shown here. This is our timeline from start to finish for our entire process implementing vector search from start to finish into our online shop. So the code isn't very complex, but what took time was creating the embeddings and getting them into the database. So how did we perform? So we have an IRIS machine running, and from that IRIS machine, we exported our items into a text file. One item, one line, with some description, some keywords, and so on, and that created an about 10 gigabyte text file. We were simply doing this because we were working in bulk and try to work fast. You can use API calls to do this, but for the bulk sake, we just created this text file. Why 2 hours? Seems a little long to just export some text, because you have to normalize the text you're putting into the embedding model. You want to remove special characters, maybe switch around some words, maybe sort them in a different way. That's why that took 2 hours. Then we took this 10 gigabytes and put them onto our embedding machine. Our embedding machine, again, we're working on-premise a lot. It's a simple Windows Server machine, 1 GPU, 1 CPU, running Ollama, which is a LLM framework, and its Python library to create the embeddings. And from that 10 gigabytes text, it created a 100 gigabyte embedding file. So again, each line, one item with its embedding in the text file. We then took those 100 gigabytes back to our IRIS server and started importing that into the IRIS database. That took 3 hours without the HNSW index. Again, here's the cost I was talking about. With the HNSW index, it took a little over double the time, simply because it has to index each iteration of the save. So everything that's getting saved needs to be indexed, and that of course takes some time. But take these 7 hours with a grain of salt, because there are different approaches to saving the data. So you can either save all of the data and then create the index, or you can create the index while saving. We only used one method, so this might even be faster if you're using the other. We can't tell you it. And this timeline is essentially what I wanted to get across today, or what we wanted to get across today is this took less than 24 hours. We were able to get started in less than 24 hours implementing vector search into a system without disrupting anything. We were working, and this isn't something I focused on mainly. I'm not an AI specialist or something. I'm just a developer doing this on the side, letting the embeddings run on the side, get started, use vector search. I'm sure you'll find a use case that can improve your use case and test as many different models as you can. And with this, I'll hand it back to my colleague, Holger.
Thank you. First of all, I would like to thank Fabio for the show, for the execution of vector search, on behalf even of our customers that are very satisfied with the new search. And certainly I would like to thank InterSystems for your support. Michael, you and your team, outstanding work. Thank you very much for the support that we were able to realize this topic so fast. So if you have any question, I think we have a few minutes, you can ask Fabio now or later on vis-a-vis. We can discuss if you want for more information exchange, for collaboration, for whatever. Feel free to talk to us. And behind there, Dietmar Tüposek, in the end as well, is part of Agimir, part of our team. You can ask him as well. So feel free to contact us. And thank you very much again, Michael, for the support. Great. Thanks.
Hi everyone. It's a pleasure to be here today to share with you our experience with using vector search in a real world, healthcare real world. We are walk through the challenge we have faced here in solution that we implemented and lesson learned along the way. Our journey involved not just technology, but also the process of change and user engagement and a lot of experimentation as this technology is in the early adopter, so we have to learn about it. My name is Claudio Laudauser, and I am the CIO of Group Sabin. And this project was developed together with Djeniffer here, Djeniffer Greffin, that is our senior solution architect. And together we combined the strategic and strategic vision and technology to solve our real problem. Sabin has here is our ideology. Before diving in technology solution, it's very important to understand the foundation that guides us. At Sabin, we exist to inspire people to care for people. So our mission is provide healthcare service and with excellence, and our vision is become a benchmark across Latin America. So Sabin is a company that resides in Brazil. The value like innovation, ethics, quality, and respect for life shape ours and approach both patient and technology. For us, digital transformation only makes sense and if it improves human experience. Our group, here you see. Our group has this kind of company. So we have a group Sabin that is Sabin Medicina Diagnóstica is a company that makes clinical analysis, pathology, image diagnosis, modernization service. We have an executive prime checkup. So we have another company that makes only looks for genomics, another company for primary healthcare, and another one that is integrated platform, service platform for healthcare. Our presence in Brazil, we are present at 78 cities, 358 service units that works 24 hours per day with mobile unit and mobile service too. We have about 30 operation and hospital center that's the place that we call a kind of plants that make exams, and with the portfolio that is more than 7,000 exams and 30 vaccines that we do the immunization service. We have about 70,000 employees, and we have more than 7 million customers, unique customers that we use the MPI, so it can have the unicity of these customers. And we have, of course, we have a search and development department that make new tests and so on. And with this environment, we have a challenger to a real world to use that technology that can help us to improve our customers' service. So I ask Djeniffer now to explain the case and the product.
Okay, thank you, Claudio. I will talk about the challenge, and our biggest challenge was to exam registration inside our list software, because we have hundreds of similar exams, names, and the options. So when the people need to register an exam, they need to ask some support to know what defines an X in the prescription. It's very hard to find the right exam sometimes. And these errors not only slow down patient care, but also lead to billing rejections, because sometimes we send this to the insurance companies and they reject our account because of these errors. And this affecting both service quality and financial performance. We also have an internal support. They receive more than 2,000 requests per day, and it's only 6 people to answer everything, because we need to have some specialists answer this question, because it's complex questions sometimes. But the mostly part of the questions are something like, what's the code for this exam? It's simple questions. So this doesn't need to go to the specialists inside our support team. And the response time were long, and the users become dependent on support for tests inside the system. So sometimes our patients need to wait 20 minutes to this specialist team answer about what is right in the prescription. And this is not, this was scalable, and it is compromised the overall experience for our customer. So the proposed solution was to use the vector database in IRIS. And we indexed the exam mnemonics. It's like a code for every exam in Brazil. We embedded technical descriptions and common insurance-related questions. So we have questions about the exams, and we have questions about the insurance plans in Brazil too. So instead of keyword matching, we moved to semantic search. That is improved the questions. This allowed the users to ask in natural language questions and get the most relevant answers based on in meaning, not exact terms. This is the challenge. It's because in search fast and relevant answers, it's not AI is good, but it's good as the data behind it. So it's not simple only to integrate with AI, and you never get the better response from AI if you not have the better data behind AI. So we worked with healthcare specialists inside Sabin to carefully curate the content. We need to do a lot of changes inside our database, and we have to get the same code and have to split this code sometimes in 20 or 13 new codes for the vector search to understand what the user is asking. And sometimes we need to remove ambiguity and ensure semantic consistency. The system needs to understand all the variations, and it only works with operated content. And we needed to do a continuous improvement cycle because sometimes the AI and the vector search doesn't answer what we want. So we implemented some kind of user feedback. So when the user sees the answer and they don't like the answer, they send it to us, oh, it's a bad answer or it's a good answer. So we get all this data and audits all this data to get inside the database again and constructing new codes to the vector search brings the better response before we send it to the AI. Every question becomes a data point to improve the system. It's an ongoing loop of learning and refining. So it's, I think it's infinite. You always have to look to this database and correct the answers every day, every day. So now, about the impact, Claudio will talk.
Well, we have some impacts using this product. Very good one, okay. The first one is we increased our service capacity without need additional hire. So the same employee can make more, transform the prescription in more exams. So this is a good. It's about we reduce the the first patient row, optimizing resource, improve the patient experience. So the patient experience is very impacted, good impacted with this product. We have a 25 reduction in that time that you use to consult the doctors or physician. So this is no longer need. Sorry. No longer need support during appointment. So our employees not do more questions. 25 reduction. They consult with this medical doctors. So we have again a reduction in revenue loss. That our employees, about 2%, that our employees use wrong code, do wrong tests. So using vector, now we do the right exam, the right test. Increase revenue to capture reduction the financial leakage, and again increase profitable and reduction of operational costs. So this is our impacts of in using this product. So we did this in a very short time. It's about less than 1 year, and this product is still getting better. It's still doing this that Djeniffer call is a loop and growing the assurance that result that we are using. More areas are internal areas, not so for our customer, is looking for use, like financial, commercial, so to put answers and let our employee to have the right questions and receiving the right answer. So using a very, I don't want to say very easy front end, but a very, very simple front end, of course, with a strong back end, IRIS back end to do the search, but we have a lot of impact, good impact, with a faster and a low-cost project. So that's the principal reason that we are continuous improvement this product. Lesson learned.
Hello, everybody. I'm Fernando Ferreira. I'm sales engineer in Brazil. It's a pleasure to be here, share this talk with my friends from Sabin. I will talk a little about the lessons learned that we learned together in this big project, fantastic project. One critical insight was the importance of choosing the right embedded algorithm, okay? Sabin tested several of these algorithms, and each time they switched, they had to reprocess the entry vector database. Tá? Depending on the size, this could take hours or even days to process. They also learned that processing matters. Okay? Things like preserving casing, removing special characters is important, or trim spaces can dramatically affect the results. Testing is essential. Okay? You can't just plug in an AI and expect it to work. Okay? And Sabin joining our InterSystems Early Access Program in July 2004, right after the last Global Summit last year. This gave them a chance to test new features, such as vector search with embedded Python and the new embedded Python property. Okay? They did run into performance issues, okay, we are in NIP, due to the way they were structured their SQL queries. Okay. Separately, while using Retrieval-Augmented 9, they encountered a little bug related to environment variables. Since they were in the ERP program, my fellow sales engineers and I support them closely, including some meetings with your product management team, which made a difference in troubleshooting and all over process. Okay, is a way to the success. And I would like to have a chance to invite everybody to participate in our ERP programs. It will be a pleasure you working and testing our new features together. Please scan the code, look at our ERP programs for these years, and participate. Thank you so much, and Claudio continues.
Thank you for your attention, and hope this presentation can show you a semantic search, how semantic search and vector technology can solve real-world healthcare challenges. If you like to discuss more or share your own experience, feel free to contact us on our emails that is on the screen. So my email, Claudio, and Djeniffer is too there. Thank you a lot.